Hi guys! Salamat sa inyong patuloy na pagsubaybay sa ating ginagawang series of discussion about statics of rigid bodies. In today's discussion, we shall be discussing about equilibrium. At meron akong nais i-share sa inyo ukol sa mga dapat nating malaman kapag tayo ay nagsosolve ng problem about equilibrium. Pag sinabi nating equilibrium, mayroong mga kondisyon tayo dyan dapat maintindihan na gagamitin natin kapag tayo nagsosolve ng problem about this type of force system. Una, meron tayong tinatawag na system of forces in a plane kapag 2-dimension lamang At alam natin, kung babalikan natin yung ating pinag-aralan last time, we will recall that the resultant force of any force system in a plane is equal to the square root of rx squared plus ry squared. But a condition of equilibrium will exist if the resultant is 0. So that if R will be 0, as in the case of an equilibrium, then all the term inside the radical sign must be 0. Okay, para maging 0 ito, kailangan yung lahat ng term inside this radical sign will be 0. Kaya, pag isinimplify natin yan, lalabas Rx, which is the summation of the force along X, must be equal to 0. Similarly, yung Ry natin, which is the summation of Ry, a force along Y, must also be 0. At dahil nga ang Ry 0, kapag ito i-multiply natin ang any moment arm, sabihin natin yung R, yung moment arm malaki. As long as the resultant is 0, ano mangyayari sa moment? Ang moment effect niyan is also 0. Sabihin niyan, if R is 0, it also follows that the summation of moment about any axis will also be 0. Even if the axis is close to a point, to any point on the Cartesian plane, as long as it is in equilibrium, then the summation of moment about any axis shall be 0. Sa mga katuwid, kung meron tayo ditong equations na pwedeng gamitin, itong tatlo na ito na lumalabas na condition of equilibrium, ito yung mga pwede natin gamitin kapag magsosolve tayo ngayon ng a problem that deals with conditions of equilibrium on a plane. But we will not only be tackling a force system in a plane. We will also have force system in space. Kapag sinabi natin force system in space, we are already dealing with a 3-dimensional force system. At kung tatandaan natin, again, ang resultant is equal to the square root of rx squared plus ry squared plus rz squared. Kaya, if r will be 0, then follows that all the forces, all the term inside the radical sign must be equal to 0, so that rx, which is the summation of force along x, will be 0. Ry, which is the summation of force along y, is 0. Ganon din sa rc. At dahil nga yung r is 0, then nasabi natin, yung summation of moment about any axis is 0. Kaya kung pag-aaralan natin, meron tayong, marami tayong pwedeng magamit na condition of equilibrium. Meron tayong pwedeng pagkunang tatlong equations mula sa force summation. At pagdating sa moment summation, pwede rin tayong magkaroon pa ng maraming equations sapagkat ang tinutukoy nating any axis dito ay could be when we say any axis, pwede siyang summation of moment about the x-axis or any axis that is parallel to the x-axis. O kaya naman pwede rin tayong gumamit ng summation of moment about y-axis or any axis that is parallel to the y equal to 0. At pwede rin tayong gumamit ng summation of moment about z-axis or any axis that is parallel to z equal to 0. Para mas lalong appreciate natin yung ating diniscuss na topic, siguro magkaroon tayo ng isang simpleng problem. At dito sa problem na ito, pakikita ko sa inyo yung ano ba yung inyo pang dapat nating malaman pag tayo nagsosolve ng problem. Maaari kung ito ay natackle na ninyo, o kaya na-encounter nyo na, kaya you may have, the problem that I'll be presenting to you, kaya nyong solvein. Pero hindi doon sa punto na ipapakita ko lamang yung solution. Ang gusto ko maunawaan ninyo, ano ba yung dapat nating malaman kapag tayo ay magsosolve ng problem. Sapagkat mula doon sa kaalamang iyon, kay mapadadali natin ang solution in dealing with an equilibrium force in any force system. Kaya solve natin itong problem na ito. Let us have the sample problem. Sabi dito, there is a cable CD that runs over a frictionless pulley and supports a weight of 50 kN, while the pulley is held in place by a pin support at D. Yan, sabi daw dito, ito daw cable CDE ay nagraran over this frictionless pulley and there is a weight of 50 kN cylinder. This pulley is supported in place by a pin. This pin, okay, supported in place by that pin. At ang tanong sa atin, we define the magnitude and direction of the force exerted by the pin support at T. Ano daw yung action ng pin support dito? Yun ang tinatanong sa atin. Pangalawa, tension in the cables AC. Itong tension daw dito sa cable na ito at sa tension dito sa cable BC na ito. Diba? So dito sa puntong ito, sabi ko nga, ito ay kaya ninyo ng solving. Pero hindi ako dun sa konteksto na ipakikita ko ng solution. Doon sa konteksto na ano ba yung dapat pa nating malaman para kapag nag-solve tayo ng problem, mas madali natin siyang masolve na. Pakita ko muna sa inyo dito yung solution. Una, sabi nga kasi dito, kung susolving natin yung tension in the cable CD at doon sa pin reaction at sa D tayo, unahin natin yung tension dito at doon sa pin reaction sa D. Sabi nga, basically, because the pulley is frictionless, alam natin yan that the force exerted by the cable CD is equal to the weight of the cylinder. Basically, but this can be shown by the concept of an equilibrium. Pwede siya ipakita sa konsepto ng equilibrium. And let us have it this way. Okay? If we will be isolating, kunwari, isolate natin itong pulley. Tanggalin natin yung pin sa loob, diba? At tanggalin natin itong kable. Pulley lang muna tayo mag-concentrate. So, i-drawing natin yung pulley. Imagine natin that this is the pulley. Okay? Enough na ba na na-drawing natin? Doon sa konsepto ng kinakailangan natin i-drawing yung free body diagram, dapat may ipakita natin dito yung lahat ng force na nag-a-act on this isolated view. So, we have to show therefore, okay, the properties. Okay, kung kinakailangan ipakita mo na yung property, ipakita muna natin. So, kung meron tayong pulley, bagamat wala siyang binibigay na dimension dito sa problem na ito, pwede naman natin siyang lagyan ng kahit anong dimension. Sabihin natin, ang kanyang radius is R. Okay, then ipakita natin yung cable. Ito yung cable na ito, sabi niya, kinakailangan ipakita natin kung alam natin ng magnitude, then we show the magnitude. The weight is 50, therefore there must be a 50 kilonewton. Do we know the magnitude here? We don't know yet. Pero alam naman natin actually that is similar to this one. But we will just be showing it as a proof. So let us imagine that is TCD. Diba? And this point, okay, will be the junction D or pin D. Diba? So we will expect that because we have removed the pin shall be exerting a component forces. Sabihin natin siya DH and there is a vertical component. Sabihin natin siya DV. So you'll notice that you have now a body that is subjected to different forces. Now, meron tayong apat na forces. 50, TCD, DH, at saka DV. 3 of them are not yet known, but we will be solving them one by one. Let's start with CD. Diba? Kapag solve natin CD, we will be taking summation of moment about this point D. You will notice that DH and DV will just be cancelled because they will create no moment. And we can have the summation of moment about D equal to 0. Okay, if we will consider one direction positive, assuming that counterclockwise is positive, then we apply the moment equation. Ano ba yung magiging moment arm ng TCD? TCD will have a moment arm equal to the radius of the pulley, and that is equal to TCD times R. Okay, similarly, yung 50 will have a moment arm equal to the radius, and that is also 50 times R. And if this will be simplified, R will cancel each other there, and you can have the value of T of CD, which is equal to 50 kilonewton. Yun yung sinasabi natin, equal din siya doon. Diba? Pero at least naipakita natin dito na yun pala yung magnitude. Okay? Ngayon, ang target natin ngayon is to solve for DH at saka DV. Yan yung isa sa mga tanong na hinahanap natin. Balikan natin. Tingnan natin itong direction ng TCD. You notice that DCD is inclined at 15 degrees with respect to the horizontal. Therefore, we expect that that angle is also 15 degrees. Ito pinakita natin dito. So, we can now apply here the condition of equilibrium so that summing of force horizontal shall be equal to 0. If we will be considering one direction to be positive, assume that to the right is positive. Therefore, we have DH. Diba? DH minus this component, 15 cosine of 50 shall be equal to 0, so that DH can be computed to be at 48.296. Diba? And then from here, you can solve for DV by summing of force vertical. There will be three forces acting. One component, you have this one and this dV. So we will be assuming that upward positive, therefore we have dV minus this one, which is 50, minus the component of this in the vertical direction, which is 50, okay, I'm sorry, 50 sine of 15, diba? So we'll be simplifying this one. You can solve for dB, which is equal to 62.941. After solving for dH and dB, we can now solve for the magnitude of d, so that AD will be equal to square root of dV square plus square root of dV square plus dH square. So when the value shall be substituted, then we have dB equal to 62.941 square plus 48.296. Then simplifying, d becomes 79.335 kilonewton. And this will be inclined at an angle equal to arctangent of dV over dH, so that if the values of dV and dH are substituted in the equation, then theta sub x will be equal to arctangent of 62.941 over 48.296. Diba? Pero hindi ako dyan natatapos. Gusto kong ipakita yung other solution. At yun yung dapat nating naunawaan kapag tayo nag-resolve ng problem. And I will show you here later on. In this case, ano? Okay? Pakita natin. Other solution is this one. Gagamit tayo dito ng konsepto na maaaring nalaman nyo na pero hindi agad nabigyan ng pansin. Ano ba yun? Sabi dito, if three forces are in equilibrium, then the three forces must be concurrent. Sinasabi kasi, kapag meron doon tayong tatlong forces at yung forces na yon ay equilibrium, asahan natin that the three forces are concurrent. At kung meron tayong concurrent force system, pwede natin siyang gamitan ng triangle method. Di ba? Pwede natin siyang gamitan ng triangle method. Itong pangalawa na ito. Okay, pakita natin. Mag-focus tayo dito sa figure nito. Okay, if I will be extending, okay, tanggalin ko muna yung R, no? Okay, para maliwanag. If I will be extending the direction of TCD beyond this part, okay? So, pakita natin yung extension niya. Next ko na. And then we also extend this one, this 50, beyond that part. Pero ngayon tayong point of intersection. If we are to replace DH and DB by a single force representing the resultant, then we expect that this AD will pass through this point, because we shall now have three forces that are in equilibrium. We have CD, we have 50, and the resultant D. And we expect that this D will have to pass to this point. Dadaan ngayon siya dito. Makita natin dadaan siya doon. Ayun. Di ba? At dahil meron tayo ngayong concurrent force system, pwede natin gamitan itong tinatawag nating triangle method. Kaya kapag in-apply natin yung triangle method, paano ba yung triangle method? Kailangan out of these forces that are concurrent, we shall be able to form a triangle whose sides will represent the magnitude of these concurrent forces. Mag-start tayo with this 50. Kunwari, drawing natin yung 50 dito. Ano? Yun. Paano bang pag-drawing ng force triangle? Kinakailangan yung second force na mapili natin, either this one or this one, will be drawn starting at the tip of the first drawn force. Kunwari, unahin ko itong CD. So, CD will be drawn at the tip of this force. So, pakita natin yan. Pakita natin itong CD. Drawing ko siya dito. Ayun ngayon. And then the third force will be drawn starting at this point until it crossed the first drawn force. Pag pakita natin itong drawing na ito dito, then that will be drawn here until it crosses that. So, ito ngayon ang nagre-represent ng force system, yung triangle na pinapakita natin dito. Ngayon itong tanong, anong triangle na nakikita natin dito? If you have two sides that are equal in magnitude, then we have an isosceles triangle. At ano baga ang property ng isosceles triangle? Ang isosceles triangle, ang two base angles are equal. Ang ibig sabihin, itong angle na ito will be equal to that angle. So kung makuha natin yung other angles in this triangle, masusunod natin itong direction ng D. Kasi itong direction ng D can be measured starting from the horizontal. Okay, pakita natin. Nasaan itong 15 degrees in the figure? Itong 15 degrees in the figure. Itong 15 degrees in the figure will represent this angle. Ito rin yung angle na yun. Yun, angle na yun, di ba? Yun yung angle na yun. Sa pagkatuwid, itong angle na yun will also be this. Okay, yung sum nito ngayon, dalawa ngayon, will become what? 105 degrees. Diba? Kasi alam natin to kasi 15 degrees. Yun. Itong angle na ito naman ay mula dito hanggang dito 90. Therefore, this will be 105 degrees. And because in a triangle, we have 180 degrees, yung 105, ibabawas natin sa 180, matitira 75. At pag hinati natin siya sa dalawa, then the angle becomes now what? A 37.5. The other angle will also be 37.5. As such, itong direction, itong D, that represents the direction of this, okay, pin reaction will be this angle. Itong angle na ito mula sa base nito hanggang doon. At kung makikita natin, ito ay sum ng dalawang angle, which is 15 and 37.5. Therefore, theta sub x will be equal to 52. At makikita natin yan, itong angle, itong value nito is the same as that value. Okay? So, yung dalawang proseso na makita natin. And how are we going to solve for D? So, itong ginito, gamitan din natin ng triangle. So, since that is already the opposite side of this angle, so we can use, pwedeng gamitin ng cosine law. O kaya naman, pwede rin natin siyang gamitan ng sine law. Mamimili ka na lang. Diba? So, kunwari, gamitin natin cosine law. How do we apply cosine law? Cosine law is the square root of the sum of the square of the two sides minus twice the product of the sides and the cosine of the angle between them, so that it is equal to 50 square plus 50 square minus twice of the sum of the product of 50 and the cosine of 105, representing this angle. So when we simplify, this D will be equal to 79.335, which is the same as this angle. Diba? Yun yung ilan sa mga konsepto na nais ko sanang naunawaan din ninyo so that when we solve other problems, you will be able to simplify your solution. Again, ano nga yung konseptong yun? When you have three forces that are in equilibrium, then the three forces must be concurrent. Okay, what else? Okay, we will continue. No? Ituloy natin. Okay, if we will be solving for the tensions in the cables AB and AC. Ito yung cable na ito. Diba? AC and AB. Paano natin gawin? So we now apply the FBD diagram. So we isolate natin yung ring as FBD. We isolate the ring as FBD. Ito yung ring representing this one. And from the ring, we draw the forces. Unahin natin itong known. Ito kasi yung force na ito is already known, which is equal to 50 degrees. Diba? This is inclined at an angle of 15 degrees with respect to the horizontal as shown here. Then this AC will be making an angle of 45 degrees with respect to the horizontal. And this tension coming from the cable BC will be making an angle of, if this is 30, it will be making an angle of 60 degrees with respect to the horizontal also. This will be 60 degrees with respect to the horizontal. So, in this case, meron tayong dalawang unknown, A, C, at saka BC. Again, I know that this problem is not new to you. You can solve this problem. Pero I know that most of you, when this will be solved, will be using the first method, yung tinatawag nating conventional method. That is the use of the horizontal and vertical. You may have wondered why I mentioned method 1. Because I will be presenting to you at least 3 methods in dealing with the forces acting on AC and BC. I know that the first method is very, very familiar to you because these are the conventional approach in solving this kind of problem, and we call that as using the conventional horizontal and vertical axis. So paano ba yun? So we are using summation of force horizontal equal to 0, and we treat rightward direction of the force as positive. So when we apply that equation, we have here the horizontal component of this, which is positive. That is 50 cosine of 15 minus AC cosine of 45 minus BC cosine of 60 shall be equal to 0. Instead of substituting right away the value of the cosine, I would simplify it by transposing AC to the right hand side of the equation, so that this can be solved at 50 cosine of 15 minus BC cosine of 60 shall be equal to AC cosine of 45. Let us imagine that that is our first equation. Let us now apply the summation of force vertical equal to 0 and treat vertically upward as positive, so that this force will have a vertical component upward, that is 50 cosine 50 sine of 15, and this one will have AC sine of 45, while this one is minus BC sine of 60 equal to 0. If AC will be transposed again to the right hand side of the equation, then this becomes equal to 50 sine of 15 minus BC sine of 60 shall be equal to negative AC sine of 45. Instead of having this as negative, I will multiply both sides of the equation by negative 1. Therefore, this becomes negative 50 sine of 15 plus BC sine of 60 shall be equal to AC sine of 45, and let us consider that this is our equation 2. Meron kasi akong gustong ipaunawa sa inyo because we know that the 45 is a special angle, diba? At alam natin at ang 45, ang cosine ng 45 ay equal sa sine ng 45. If this equation will be multiplied both sides by AC, then we shall have AC cosine of 45 equal to AC sine of 45. But what is this AC cosine of 45? Isn't it that is the exactly the first equation? And AC sine of 45 is exactly the second equation. So that if equation 1 and 2 will be substituted with their value of AC cosine of 45 and AC sine of 45, therefore this becomes equal to, mangyayari ito, 50 cosine of 15, manggagaling siya dito, plus dito muna tayo sa baba, 50 cosine, yon, minus 50 BC cosine of 60 shall be equal to negative 50 sine of 15 plus BC sine of 60. At mapapansin natin, you have here one equation involving BC. And so we can also solve for BC here. BC will be equal to what? When we simplify, BC will be equal to 44.829. So that if BC will be substituted in either equation 1 or 2, then we shall have AC to be equal to 50. Dito ko siya sa substitute, 50 cosine of 15 minus BC cosine of 45 divided by cosine of 45 degrees. Diretsahan ko nang ginawa yan. Kasi I know that most of you already know this concept. So when you simplify, you can solve for AC to be at 36.603. Diba? Ngayon, meron akong gustong tanong sa inyo. Yung gano'n ibang klase ng approach, madaling gawin. Madali. Subalit, matagal at o kaya mahaba. And because you have more computation, more write-ups, there are also chances, there is also a possibility that you'll have more errors. At yun ang iniiwasan natin kapag tayo nag-solve ng problem. Kaya, kumisan humahanap tayo ng simpler solution in order to eliminate the possibility of committing error. And so I will show you here the second method. Second method is the use of a selected reference axis to facilitate computation. Sabi nga, the selection of a reference axis to facilitate computation is always an important consideration. Bakit ba? Tingnan natin mabuti, ano? Itong ating sistema, meron dalawang unknown. Ano kaya kung sa pag-solve natin ay we try to eliminate immediately one of the unknowns? Makatuwid, we can solve for the other unknowns. Di ba ga? Ito yung susi. Now, instead of using the conventional horizontal and vertical axis na gaya ng ipinakita ko sa method 1, we will be selecting the direction of one of the unknowns. Take note na, we will be selecting the directions of one of the unknowns as the reference axis. There are two unknowns. I have AC, I have BC. Suppose I will select the direction of BC as a selected reference axis. Instead of using x-axis, I will be using x prime para tukoy ko na ito ay simply used in the computation. Okay? Ipakita ko, kunwari ito yung aking x prime axis. Pinakita ko dito, no? That is the x prime axis. Pagkatapos, gawin natin, we try to define the angle that the other forces will make with the selected axis or the axis, ano? Pumili tayo ng x-axis. kunin ngayon natin yung angle that this AC at saka itong 50 that this will make with respect to the x-axis. Sa mga katuwid, ito yung ating hinahanap. Ano kaya itong angle na ito na nagbiblink dito? Pag-aralan natin. Okay? Itong sum itong tatlo na ito, because these are supplementary, dapat ano ito? Dapat siya ay 60, 45, 105. Ito dapat ay 75. Diba? At itong angle naman ito, na 50 that is making with respect to the x prime axis. Diba? So, alam natin ito 60, ito din yung 60 na yun, di ba? O, babawasan ng 15, sa mga katuwid ilan yun. Yan ay matitira 45. Di ba? Ngayon, medyo linaw-linawan natin. Bawasan natin ng konti para hindi ganong kailangan. Tanggalin natin yung other angle. Yan na lang yung nakikita natin. Okay? Meron akong gustong papansin sa inyo. BC. Okay? By the way, we have selected x prime as the reference axis. We shall have, therefore, y prime as an axis that is normal to the x-axis. At ipakita natin itong y prime. Tawagin natin siyang y prime. Meron akong gustong ipaunawa sa inyo. Sabi ko nga, since BC is directed along x prime axis, my question is, will this have component along the y-axis? Di ba wala siyang component along the y-axis? Mga katuwid, if it has no component along the y-axis, sa mga katuwid, if we will be summing up along the y-axis, then we shall be able to eliminate BC right away, and AB can be solved. So that, summing up force along y, okay, this one is direction, assuming that that direction is positive. What are those forces that is directed in the y direction? We have the y component of AC and the y component of this 50. With the equation to be AC to be positive, AC sine of 75 shall be equal to 50 sine of 45. Kaya in this equation right away, you only have one equation, which is AC. And therefore, AC can be solved to be 36.603. At siya din, the same value that we have just taken a while ago. Now, if AC is already taken, now we can solve for BC now by summing up forces along the x prime axis. Saka lang natin siya gamitin itong axis na ito. Diba? So that, when we sum up force along x-axis at tawagin natin itong positive, then we have AC cosine of 75. Yung component itong AC na ito. At yung component ito, that is 50 cosine of 45, will be equal to, minus BC will be equal to 0. So that when we substitute the value, okay, this will be equal to BC. And BC will be equal to 44.829, exactly the same value that we have taken in our first method. So makita nyo yan yung, okay, yung simplified solution in solving for that unknown. But there is still a shorter solution, and the other one that I have presented in the computation for the pin connection, and that is what we mean by the use of the force triangle method. Kaya lang, itong force triangle method, may limitation ito ha. Ito ay ginagamit lamang natin kapag ang force natin ay tatlo lamang that are acting concurrently. If we have 3 concurrent forces in equilibrium, then we can apply the force triangle method. Paano ba yan? Again, pagpili dyan, kinakailangan may drawing natin yung forces in triangle. By selecting any one of them to be drawn first, and the second will be drawn at the tip of the first, the third will be drawn at the tip of the second. So, pakita natin yan. Kunwari, ito yung point natin. So, at this point, we select which of the 3 forces shall be drawn first. Kunwari, piliin natin itong 50 na ito. Diba? 50 is making an angle of 15 degrees to the horizontal. So, if this you have the horizontal and you have the 15 degrees, then this will be the direction of our 50. Then at the tip of that 50, nakita natin ito, di ba? Okay, at the tip of 50, we try to draw the second force. Halimbawa, itong BC yung pinili natin. BC makes an angle of 60 degrees with respect to the horizontal. Therefore, from the horizontal, at 60 degrees angle, we draw our BC. Then at the tip of that BC, we draw the third force, itong AC naman natin. Diba? And then from there, AC is making 45 degrees. From the horizontal, at an angle of 45 degrees, we draw our AC. And afterwards, what shall we do? We now try to define the interior angles of the resulting triangle. Kunin natin yung interior angles, yung angle neto, dito, at saka doon. Magsimula tayo dito. How are we going to solve for this? Okay, tingnan natin, no? How much this angle will be? If this is 60, then this will also be equal to 60, diba? And the sum of all these triangles will be 185. Kaya kung ito ay 60, 45, ano ngayon to? That must be 75. Diba? Similarly, anong angle ito? Diba? This angle is 45. Therefore, if we wanted to solve this angle, how much is that angle? The sum of 45 and 15, and that will be equal to 60. And then knowing the two, 60 and 75, how much will this angle be? That must be 45. So medyo palinawan natin ha. Tanggalin muna natin yung lamang angles na hindi natin gano'ng kailangan. Ano ngayon meron tayo? We have here formed a triangle having 3 known angles and 1 sides that is also known. The 2 other sides can be solved using function of sine law, which represent the unknown values of this fourth system. Therefore, using sine law, you have the side to the sine of the opposite angle. BC is here, opposite angle is 60, therefore BC sine of 60 shall be equal to AC. Sine of 45 shall be equal to 50 sine of 75. And that, from here, you can solve for AC equal to 36.03 at BC equal to 44.829. So guys, yan ang ibig ko sabihin na what else you should know when dealing with a force system in equilibrium. You learn how to simplify solution using the method of selecting some rotated axis, or the application of the force triangle in solving for the problem. As well as the concept that when you have 3 forces that are in equilibrium, then the 3 forces must be concurrent. Sana nasundan niyo yung aking discussion at sana patuloy niyong subaybayan ang ginagawa natin discussion. In the future, we shall have more topics to come. So I suggest that you subscribe to my channel, o kaya naman ay you share it to your friends so that they will also know and notified with my uploads about the topic. Thank you for watching.